When predicting trends in foreign exchange markets, most algorithms to date study price changes against time. This paper, co-authored by our very own Colin Johnson, investigates a newer approach of studying price changes against market events, called directional changes, which enable programs to observe changes of the market which would otherwise be missed when concentrating on physical timescales. This allows for improved profitability of market forecasting programs. These directional changes are divided into directional change events, which can be measured, and overshoot events, the duration of which this paper looks to predict using a genetic algorithm. Trends in the market are summarised by upturn directional events and downturn directional events. The threshold for defining a directional change event, shown here in red, is decided by the trader, and then once a trend meets or surpasses this threshold, we enter the overshoot event, shown here in green. This paper aims to formulate equations that, using these directional changes, can predict the duration of an overshoot event, thus allowing traders to develop a profitable trading strategy. This paper references two previous papers that have successfully described these two relationships here between the duration of the directional change and the overshoot events. However, both of these relationships are linear. The purpose of this paper was to find a more general, non-linear solution to the problem in the form of this equation here, which will be able to more accurately describe the complex and chaotic nature of the foreign exchange market. The paper's genetic program was tree-based, much like those seen here in the diagram. These trees represent two possible equations that the genetic program could produce. Inner nodes of the trees were comprised of linear and non-linear functions, and the terminal nodes contained directional change lengths and constants to be used in the equations. The fitness of a model was measured by minimising the root mean square error of the overshoot length, shown here, where models were discarded via tournament selection. In the case of two candidate models with the same fitness, the model with the shortest depth was selected. So, what were the results, and how did the genetic program compare to previous genetic programs and trading algorithms? The main comparison was made against the two linear equations introduced earlier, and the results are summarised here in this table. This table compares the average rank of all the strategies in terms of profitability, and the statistical likelihood that the values were all obtained from the same distribution. Clearly, the table shows that the genetic program in this paper outperformed both of its predecessors greatly. So, this paper concludes that estimating overshoot length provides a profitable strategy for foreign exchange market trading, and that the methods used within were more successful than previous attempts. But what else is there to do? Well, there's still room for improvement in the genetic algorithm using different genetic operators to uncover richer descriptions of overshoot length estimators. Furthermore, additional data sampled more frequently over a longer timescale will make the analyses more robust. While the work in this paper is promising, it is still yet to be seen whether the methods developed can be further improved to truly maximise the profitability of foreign exchange market trading.